Hi guys, welcome to more one AI science video of my channel. I wish you like. Today I'm going to talk about large language models and how can this kind of model could be used to predict analysis. So, large language model is commonly used for text purpose, for text generation, text classification, and something like that. Today, going to use these models to predict the time series data. Okay, uh, let's go. Large language models transform text input in text output using numeric representation of the text. Uh, and we have foundation models. Foundation models are a form of generative AI that generate outputs from one or more inputs, prompts, in the form of human language structures. These models are used for fine tuning in a specified problem. You have models training in unlabeled data for generic problems, and these models are used to fine tuning for your problem. Foundation models are training with massive unlabeled data to handle a wide variety of jobs, from translating texts to analyze medical images. So you're going to use today this kind of model for predictive analytics, okay, to predict the future with a time series data. For this, you're going to use a time series tokenization. In this context, time series are used as a text, is the same way of a text. You have tokens. Each number of the time series are like a word, and you have tokens here, and you train the model in the context of the tokens, and the model going to predict, to forecast the data. To use this, so today we're going to use Chronos. Chronos is a new API for time time series predictions using large language models. Let's go. Hi guys, we're going to use Chronos in Colab now. The first thing is to clone this address here. This address is the address of the API Chronos. I'm going to clone this and move to this directory. This directory is the directory of sample of forecast of Chronos. We're going to install Chronos forecasting, and to install the requirements here. Now we're going to start to go into the folder of Chronos, install NumPy, the version 1.24.4. This is necessary because you have some problems with dependencies. You're going to import all necessary libraries, and here you have some variables. The time column, there is date, the targets, that are the numbers of visits, the state covariables. I'm going to talk about state covariables, the dynamic covariables, this inflation rate, the GDP is something that I want to forecast. The frequency here, the month frequency, the forecast horizon, it's 8 months. The scalar, the scalar that going to normalize the data. Okay. Usually, you have two kinds of variables. You have the static covariables. The static covariables are variables that don't change in time, like store location. The location of store is the same in the all time series. The dynamic covariables are covariables that change in time, like the number of products buy in some day, the health of some day, the temperature of the location in some day or in some hour. This is the dynamic covariables, uh, or covariates. So you have static covariates and dynamic covariates, and we're going to see this now in code. Now in code, we can see the data frame here that going to be downloaded, the data.csv, and the time column is changes for the time with pandas. And now we're going to show the first rows of the data set. Here you have the date, the unique ID, the number of visits, this CPI, inflation rate, GDP, and static variables, static features, static 1, static 2, static 3, and static 4. And here you have the time series created from data frame. You have the static covariates, the time column, the target that I want to predict the value here, the target, and you have the frequency. The few missing data is true, so the algorithm going to few missing data, and few NA value with 0. You have for training 220 rows, and for testing 8. Okay. uh, Now you're going to set the dynamic covariates and the static covariates here. This is the static covariates, and this is the covariate time series. You have the attribute 1, you're going to use one hot encoding, and you go to forecast for 8 months. And you're going to create this data frame here and stack this data, the covariates field, and append to dynamic covariates. So you have all this, and you're going to use a model named tide model here. This is the parameter here, and you go to fit, to train, and to predict. And now we're going to use Chronos model. The Chronos is a large language model used for time series using CUDA. This is the model. The Hugging Face is going to download the model. You have pre-trained model here, and you go to uh, loop in the data. You're going to forecast everything here, and now we're going to forecast here, and you can see the Chronos model do very well here. This is the real data. Yeah, this is the prediction for the interval. This is the real data, and this is the prediction for the interval. We see that Chronos is really good in this sample. Okay. I wish you like. This is the Chrono API for predict for time series using large language model. I need to you like the video or unlike the video and comment in video to my channel. Go the algorithm of YouTube send my channel to other people. This is important to support the channel. And we see you in the next video. I really wish you like, and bye bye.